Hello everybody, welcome to my tutorial. I'm going to be talking about the principles and fundamentals of modeling, 3D modeling, namely like what it is, how it works, how a game system actually like understands and renders what a model is and how it moves around and things like that. And then I'm going to talk about the differences in the software that we currently have and the software systems that you have to use if you're going to want to put your models into uh, specifically a RuneScape private server esque type server, just anything that runs off of that Java program. You don't actually have to be running a cache or trying to make money or anything illegal like that. I'm not actually proposing that. I'm just showing people how to get their own custom models into their own servers, and that's it. And then after that, I want to talk about the workflow that it goes through, the apps that I use, and then I want to talk about just the overall recommendations that I have for making the models better and stuff like that in the community. Now, before I really jump into it, I just want to say that I'm making this tutorial because I started doing all of this back in I don't know, 2019, and it took me probably 2 or 3 years of just working around and reading tutorials and asking people things to feel like I got to a point where I kind of truly understood how all of this works. So I feel like if I can just take 10 minutes in the beginning and summarize how models work for you guys and how rigging works and stuff, then later on, the rest of the tutorial is going to make a lot more sense. You're going to understand what I'm doing intuitively. So if you need to, rewind to this part here and just keep rewatching from here forward a few times until you understand everything that I'm saying, then please do that and then move on. Okay? So to start, a model is simply a 2D or 3D object that we can make in a number of different software applications. I'm using Blender. It's free. You can download it for free. You can donate if you want. You can pop it open today and you can start working on it. There's a plethora of YouTube tutorials that will teach you how to actually like make models in Blender. Which I might, do a video later of me doing like an actual model, but not right now. So the software itself is free. You can download it, and in here, you're making 2D and 3D objects inside of this virtual space. It's called a viewport. Um, and inside this viewport, not only are you making these 3D objects, but you can set up a scene and you can set up lighting and cameras and you can render animations inside of this. So when you see, like computer generated commercials, or not computer generated, but just like computer graphic commercials, things like that, that are, obviously not real and they're made in some type of software. It could be made in something like this. You can come in here and you could make a fake prototype of a phone. You could put up some lights in the background and you could put a camera in here and you can have the camera do a 360 around the phone to show it off. And that's, an animation in a commercial. And in that, the phone is the model itself and it's just a shell. It's, there's nothing actually going on inside of it. It's just for looks so that you can actually display something. And that's essentially really what any model is. If you were to take this cube that I have right here and we were to go into it and we take this front face and we just hide it real quick. Oh god, sorry. Then you can see inside it's hollow. It's not filled up. It's not full of anything. It's just an empty shell. So on that note, every model is made up of a few key components. We have the faces. That's what I'm clicking on right now, and that's pretty intuitive. We have the edges, or, some people would, yeah, it's just the edges. And then you have the verts, these are the corners. these are the different vertex points that make up your model. So you have your vertex points joined together by edges, and then you can fill them in with your faces. And that is what is consisting of a model. And then when you have filled it in with faces, your faces have what's called normals to them. And essentially that just means that they have a specific orientation. They're facing a certain way. And I mean, that's just kind of logical. Think about anything in the real world. Like, it doesn't have, you can't see it from the back side. You know what I'm saying? Like, everything faces a direction, I guess. So anyways, if you turn on face orientation here, you can see quite quickly, if we hide it again, that everything in the red is what is normally like the invisible part of the face. And when I say the invisible part, what I mean is you actually can't see it from this side. So let's say I took this exact cube as it is right now with this face missing and I put it in game. If I was looking at it from this side, I would say, oh, cool, a little cube box. And then if I went around to the back, I wouldn't just see an empty open cube in the back. It would literally look invisible, and I would see nothing. I would see into the distance through this cube because it doesn't render information on this side. So that's what I mean when I say normals reflect the way the face is going, and that's something that you need to pay attention to. And it's also something that you can utilize too. It's a really cool effect if you specifically want it to be seen through. And I can get into that later with a different tutorial. So we'll bring that face back. Now that we get into it, there's a few different types of faces. You have quads, which are made up of 4 verts. You can see that right here, 1, 2, 3, 4, and that's why it's called a quad. It has 4 verts. You have tris, which are made up of 3 verts. 1, 2, 3, and it's split up, so that's how you would split up a quad. And then you have what's called n-gons, and that's just anything more than that's just anything more than 3 or 4 verts per face. So right here you can see there's 6 vertices per this face, and there's no edges in the middle to break it up. I mean, why is all of this important? Sorry, it's probably confusing you. Why is all of that important? Well, because when you're putting a model into a game systems, rendering software, things like that, where there's like, you know, a camera and it's looking at the model and it's displaying it to somebody, it can really only read triangles. So if your model is made up of quads, or your model is made up of n-gons over here, then whenever you put it into whatever software you're using, if it doesn't air out, then it'll automatically triangulate the model itself into whatever it thinks is the most convenient form, and then it'll display it to the person. So all that to say, when you're making your models, you need to think about how many triangles in total are making up your model, because the more triangles, the more demand on your GPU and your CPU. And especially for the older games like the ones we're going to be talking about later, you really can't go that high in the triangles. You can do things to increase it, and I will talk about that, but even just increasing the triangle count doesn't really help all too much. You still can't go that high. It doesn't render that great, and things like that. So now that you understand what a model is and the faces and things like that and how a system sees it, I want to talk about the coloring it in real quick, because that is a little bit different too. There's 3 options that go with coloring in your models, and I'm going to flick this on so you can see the colors real quick. Right here in the middle, we have it flat shaded, or just, you know, hand colored, whatever. I mean, it's not hand colored, that's not what you would call it. It would just be called like flat shaded, or just, you know, regular coloring, whatever you want to use. This is all generic PBR values inside of Blender. So what I'm doing is, on every single face, I'm assigning whatever color I want from this list of colors that I made over here, and all they are is just generic PBR values, and then you can play with the metallic and the roughness and the alpha and the transfer and everything inside of Blender. A lot of those properties don't really carry over whenever you're trying to export it from Blender into something else. These properties really only affect the rendering inside of Blender. That's not entirely true when you're doing it for, the newer systems. Then definitely they've engineered some ways when you're exporting your models in certain formats that you could bring these qualities with it. And even the new Blender 5.0 update is insane with it and how good it got. But for the old purposes that we're talking about, it's just simple. It's this. Over here on the left, you'll see we have a model that's textured. And what texturing means is you essentially take this model that's made up of 2D pieces. So remember, I said it is a 3D, image, it is a 3D shape. It's a cube, but it's made up of 2D pieces. It's just these sides pasted together. So what you can do essentially is you take your cube and you cut it open and lay it out flat. Imagine a cardboard box. If you cut open the seams on a cardboard box and you laid it out flat, and then you took a picture, a 2D image over here, that's my palette right here, and you glued it across the box, and then you taped it back up. I'm pretty sure almost everybody's done an arts and crafts project like that in the first 2 or 3 years of school. So that's what texturing is you're taking a 2D image and you're stretching it across this 3D surface. And then from over here, you can mess around with things to give it different colors. That's a whole other thing. And that's, actually learning the process. But that's what texturing is. And then the third option is hand painting textures, which is where instead of taking this 2D image, you essentially color in your own image onto this flat 2D surface that you made over here. That's way more in depth. Don't even really use that for the old school RuneScape models anyway. But that's more of exporting this model, taking it over to a different program that's kind of like Microsoft Paint almost, and you're literally hand painting it with a pen onto the model to get the look that you want. So now that you guys know models, you understand what they're made of, you understand the ways that they're facing and how a computer sees it and the different colors and everything that goes into it, I can introduce rigging. Rigging is when you want to actually animate a model. You want to get your model to move and do things. You can't just drop this human. I'm going to hide this because I don't want to confuse you guys. You can't just drop this human into the middle of a video game and expect a computer or Unity to understand, oh yes, this is person, let me rig, let me move, let me make all human animations, and I know exactly what I want him to do when you tell me to jump or to do whatever. Some of the super new systems like Unity do have implementations where they can auto rig it, and they have some basic animations set for just humans or something. But if you made a custom monster and you wanted to rig it and animate it however, it doesn't do that. You need to rig it yourself. And so what that means is you're essentially putting bones inside of your model and then assigning the faces of your model to those bones so that you can move it around and manipulate it without actually messing up the model and going back to a starting point later. You do this so that you can make your own animations, because in game, again, your model doesn't just do whatever you want it to do. It has a set list of things that it can do based on the animations it can perform. So if you want the model to jump, then you need to have an animation playing where the model looks like it's jumping and then comes back to, the ground, back into a running stance to then run again. So to do all of that, like I said, you need to put bones inside of these models that let you control how to move the model, and then you go through the process of moving the model and recording it and everything, and that's kind of almost like a little flip book that you would make as a kid where you would draw on each page, and then when you flip through it, it looks like it's moving. Same process, much more easier with these 3D applications. And again, that's not what we do with RSPS, but I'll get into that in a minute. So let me unhide the bones now. These little guys all sticking out all over the place are called bones. And I just already got a rigged human so I could just simplify it and show you what I'm talking about and stuff. If we go into pose mode for this rig and we select this bone right here and we move this bone, you see how the whole arm moves, and I can move it to a place and I can stop it and oh, I'm not going to do that. I'm so sorry. We can stop it, and it doesn't really actually distort the model. It doesn't mess up the mesh, because you can see it's right here, and you know, maybe the armpit's a little like smushed off, but then if I move it back up, it straightens itself back out. And the way it does that is through texture painting and weights. So essentially, if you were to go into, yeah, let me pull it up. I'm so sorry. This is texture painting. Yes, I don't need that. I need to pull up the model to show you the texture painting. Oh my God. Weight painting. Jesus, there we go. Okay. So, anyways, now I can show you a lot better what I'm trying to say. I'm so sorry. So these bones are connected to different parts of the body. And what you do is you go through with your mesh, and every single vert that you want to be connected to a certain bone, you highlight that vert and you say, I want it to be part of this bone. And you have to aptly name them together for it to work and for it to understand that, for it to link them together. That's just kind of how any software system works. So you have what's called vertex groups, where, and I know it just looks like all black and a giant thing of red, but if you were to zoom in really close, these are all different little points, and they're colored differently in between. So where it's red, the weight is higher, meaning when the bone moves that these vertexes are aligned to, this one right here, when it moves, the vertexes that are red that have a higher weight are going to move harder. They're going to be more influenced by that bone moving. And it makes sense because they're the ones that are right on that bone. So if I moved this bone, I would want these to move directly. And then the ones that are lighter colored out here, more cooler, are lower weighted, and that means they're less influenced by it moving. I would still want them to move. It makes sense. If I turned my forearm in real life, the inside of my elbow is going to be influenced by it, not as much as this part right here would be, but it will be influenced by it a little bit. So that's how all of that works. And like I said, it all works through making a bone, giving a name to the bone, and then giving a name to the groups of verts that you want to be influenced to that bone. And when you have all of those working together, then you're able to actually go back, and yeah, I know, I'm sorry it took me so long. You're able to go back and you're able to move that bone, and you're able to influence the other verts around it. Like I said, see how it's affecting that elbow just a little bit, but these verts are moving way more than these verts are. That's how it works. And then you also have, just real quick, you have parenting. So like if I'm moving this one, then it just moves all of the ones down the line. That's how that's influenced. Anyways, because certain companies, I'm not going to name them, wanted to safeguard how to actually make these processes and things like that, and to safeguard their, models and assets from being stolen, they don't rig in this conventional way. And this is what a lot of developers in the scene do not understand. So you can't just download a model from online and have it rigged like this and throw it in your game and expect it to work. It doesn't work like that with RSPSs. You have to rig it using specialized software, because that's what jagex did. I name drop, sorry. That's what they did, and that's the softwares that they formed and stuff, and that's just what we have to use to be able to get the models in there and talking together. So what I'm going to do now is I'm going to walk you through using the two other software systems that I would use after this point to actually rig the model, get it scaled right, get it colored and everything, and then get it in game. So let's pretend that we just made the model. It's not actually rigged or anything like that. We don't have these bones because none of these would translate over trying to get them into RuneScape anyway. I'm just going to do a little helmet real quick to show you. So we can close this, doesn't even matter. Right here, we got our little dude open. And this program is called Metasequia. It lets you model as well. I just don't use it because it's a little obsolete compared to Blender. It's a little harder, all of that. I just prefer to use Blender, import my models into here, and then go from there. So what I heavily recommend is starting with an NPC character. If you're doing like a generic human, you want to have an MQO already open when you're importing your Blender file. The main way that you want to export your Blender file, I would just say, is exporting it via .obj, and then opening up an MQO file in here. When you open up the MQO file in here, you'll have this palette already auto-generated on the right. You need to have this palette in here and above all of your materials, or it will throw an error. It just will not load right. Up here, you have your different layers. Now, I want to talk about these real quick because people don't understand what these are, and this is the main key component on troubleshooting your models to see how it works, trying to fix, like I said, trying to troubleshoot, but yeah, fix things. It's how you rig, it's how you do everything, and now that you understand what I talked about with rigging, this will make much more sense to everybody. So each layer is a different form of data for the computer. You have your first layer, your top layer, your model layer. This is the one that you made, the one that you color, and the one that ultimately the player will see. Then you have your priority layer. Your priority layer tells the computer what is more important in terms of rendering, i.e., what do I show on top of the other thing? And a really easy way to explain that real quick is the numbers on the side here, 0 through 10, are the ones that you use in color coordination to lay out the different priorities that you want. 0 being the least and 10 being the highest. So if something is 10, I want it to show through something else. You can see right here, the chest is 3, but these little X's, these little X patterns that normally the player would show up over here is 4. It's 1 higher, and the reason being, you're telling the computer, I want these to render over the chest, so the part of the face that's behind this X, I don't want that to show, I want the X to show instead. And that's essentially how the priority layer works. Now, a lot of times people will just come in here and they'll set their models to just 0 over the whole model, and that will work when you're using one piece. Or I'm sorry, it'll work when you're using like the entire armor set together. But when you mix and match different pieces, you'll see very quickly that it falls apart. And the reason is when you're putting a model in game, it's replacing that piece of the character with that model. So if you're putting legs on your model, it quite literally says, oh, okay, we're putting custom legs on. Cool. Delete player legs, not the boots down there, sorry, but they're touching. Delete player legs and insert the model legs. So if your model legs are not the right priority color, but then you have, and it was working with the entire set, but then you have like an old school RuneScape top up here that has not just the 0 priority layer that you made, but it has the proper priority layer, it might mess up with the rendering settings. So it's really important to always remember to actually do the proper priority layer for your models. Next, you have the T-skin layer. Now this, I know that it's colors, but what it's doing is it's telling the system the name of the bone. So remember when I said every single thing you rig has to have a bone, and it has to have a vert group and a name to the bone for the computer to know like what verts go with what bones, and then they need the weights together. Well, this is how you tell the system the name of the bone. The system already has all of the names of the bones in there because you already have all of the animations and stuff in the game. You're copying existing animations. So by giving these different sections different colors, these are actually telling the system different bone names. It doesn't see color 18, it sees, oh, right shin, because it's all of that color. So everything in this color is right shin bone and should move when right shin bone needs to move in an animation. Same with chest, same with neck. Now, the V-skin layer is where you put your weights. And remember how I said that, you know, if you have this entire bone going through here, then like this weight might be the most affected and this one might be less affected, so it might be less. And then, you know, so with this one, that's not really how it works in this software. In this software, just the way that it works, the way that it got designed and everything, every vertex that's inside of a color is all going to be the same weight. Every vertex that's where two colors meet, and it's where two colors merge, that's where two bones meet. So the weights are going to be different there. And what I mean by that is like, so the weights on the arm in this area might be 29. All of these different little verts, you're going to click on them and you're going to put the weight over here as 0.29. And then these ones might be 0.30. And then these ones might be 0.31. And what that denotes to the system, it goes along with the pairing of making the different colors for the different bones. But what it denotes to the system is, yes, all of the verts inside of this are on the left forearm. All of the verts that were labeled 19 are right where the forearms connect to the bicep. So I know that's where it needs to bend properly. So it's just, these are the two different bones and weights working together to tell the system how to move. And then your priority layer is the rendering. And then your model layer is what everybody sees. So that is the different layers in a sense. So now I'm going to show you real quick, just start to finish. You can insert a model. I'm going to use one that I already have kind of made. And I'm just going to walk you through rigging it real quick. I'm so sorry. My eyes are not what they used to be. Oh, I have it open in something else. That's right. Okay. So when you go to insert a model, it's going to pop up with this. And like I said, if you already have an MQO file open, great, because you already have the palette over here. So for materials, you're going to select merge rather than create new. If you create new, it's just going to try to create new materials underneath and possibly new palette. It's going to ruin everything. Just merge your materials. That way it'll just add any new custom materials you may have to the end of this list. And then as far as objects, you have two options. You can merge or you can create as a new object. If you merge, then your model is automatically going to be assigned to this top model layer. It's going to be joined with it. If you create it as a new object, it'll add its own layer down here. So that's what we're going to do. You see it loaded right here. And if I was to hide the character, all of the layers for the character, we can see that it's right here and I can toggle it on and off. So what I did was I essentially made its own model layer, and I can just go ahead and rename it model. Now, normally when you load your model in, it might not be perfectly scaled and centered and everything. This just already is. It might load in down here in tiny, or it might load up huge or whatever, and you might need to scale it down and move it and get it to line up. What you want to make sure is that you get your vertex points to line up perfectly. Like if I hide the actual models so all you can see are the vertex points, then you can see right here where the neck lines up, these verts are perfectly flush together. And what that means is when I go to equip this helmet and the game says, oh, okay, we're putting on a player helmet, let me delete the player character's head so I can display the helmet in its spot, it's going to line up perfectly with the neck and you're not going to see any gaps. And I'll show you later what that looks like in game because it looks terrible. So anyways, we got it all lined up. We don't need the NPC model anymore, so I'll just go ahead and delete that. You can come up here to delete layers. You just highlight the one that you want to delete and hit delete. From here, we already have the model layer that we want. We can just clone it to make more copies. So I'll just clone one. We're just going to start off with the priority layer. I hide the one that I don't want to mess with. We already have the model layer made. That's the one that the computer is seeing. I don't want that messed with. Now we only have this layer showing, and I can double check by just, yep, it's that one. I can come in here and I can rename it, and I want to change it to PRI for priority. All capitals with the colon after. You have to do it that way. You have to type it out specifically and exactly that way, or it just won't work. For her heads, the priority layer is 6, so I'm just going to go ahead and I'm going to color it in with that material. And I'm going to go ahead and make a new priority layer, or just a new layer. I'm going to go ahead and hide that one, and I'm going to rename this one T-Skin. This is going to be the one where we tell the system what bone it is, and we have the head bone and the neck bone. So there's going to be 2 different colors. We'll start off by making it all white, which is the head bone, and then red for the neck, and we're just going to color one layer all the way around. And there we go. That's how the head will look for coloring in the bones. And this is literally telling the system one neck bone right here and one head bone right here. From here, and this is a trick that I'm going to give you guys, a lot of people think that the V-skin layer needs to look like the model layer because when they export models, it just happens to be looking like the model layer for the V-skin. But the fun fact is the system doesn't know or care what the model looks like color-wise on the V-skin layer, which again, we're going to come in here. We're going to name it VSkin1, colon. It doesn't care what colors are on this layer. It only cares about the weights that we're going to be inputting on this layer, telling it, how much to influence what. So what I recommend is make your model in order of these layers and then copy your T-skin layer, because I already gave you that hack earlier. Everything that's on this white color is all going to be one weight. Everything that's in this red color is going to be one weight. Everything where it meets is going to be a different weight. So you can do that as a nice visual representation to keep yourself lined up of going, oh yeah, that's where they meet. That's where the lines are and stuff, because it might get a little bit harder with more complex models later to keep that line. You can have up to 3 V-skin layers. If you do, then every number in each V-skin layer just adds on top of it. So like if I had this vertex as a weight of 0.01 on V-skin layer 1, and then on V-skin layer 2 I had it as 0.01 as well. It just adds up the layers, so in total this vert is going to be 0.02. Why would I do that? Well, some vertexes need weights above 1, and you can only put a max of 1 on each vertex layer. And the reason that is just because that's how the software was set up. They have so many animations, blah, blah, blah. Anyway, for basic humans, you're only going to need just this first layer anyways. So that's what we're going to stick with today. But if you come in here, we're on VSkin1. Currently, we haven't weighted anything. I can come in here, I can use the rope tool, and I can select every single vertex. Now, I can give it a weight of 0.01. Why would I do every single vertex at once? Well, because it's just nice and simple and easy rather than trying to avoid clicking on the few ones that I'm going to need to change later. So I just highlight all of them. I put them as 0.01 real quick. Now, like I said, where these colors meet, it's going to be a different color than it is where they don't meet. So I highlight all the ones along that edge where the colors change, and those are going to be 0.03. Lastly, the bottom, because this is where it would be touching the torso, it changes to 0.02. And there you go. You have weighted everything on this layer appropriately. And again, because the computer system doesn't care what the color is, you could keep it white and red to help yourself. From here, all you have to do is just show all of the layers again and unlock them. Make sure that you spelt these right. These need to be all capitalized. The top layer, it doesn't actually matter what you put in here. I just put model with the colon to be nice and easy and simple, but these ones are the ones that matter. You need to spell them properly in that way. From here, you can go ahead and save the file as an MQO, not an MQOZ. You just want to save the file as an MQO. And we're going to go ahead and we're going to overwrite that. We're going to save it. From here, you can go ahead and take your model and you can import it into DATmaker. DATmaker is how you convert the model from an MQO over to the DAT format to get it into your game. Once it's in here, I mean, you load up the program. When you're here, you can open up either a single model at a time by selecting them, or you can open up an entire folder, what I recommend. And then you can just scroll through here to the model that you want. Now down here in the bottom, they did select stuff for like putting animations in and stuff, but we already rigged it. We did everything in Metasequia. So you're never gonna actually touch this, and that's why DATmaker's like doing everything in Metasequia is awesome, because you can just come into DATmaker, you just hit make DAT, and it automatically makes a copy of this as a DAT in your folder so that you can use it in your game. You just import it right into your cache. The other thing that's great for DATmaker is while you're in here, you can double check that you did everything right. In the top here, you'll see some displays. If I click priorities, it'll display the color. Remember I said that, you know, all the heads are priority color 6. Well, right here, it's displaying the color that I painted on every single vert in the model. So I can come in here and I can double check and I can say, oh yeah, the system is actually reading for sure that I painted it color number 6 and I did it right. I can come in here and I can select T-skin and I can say, ah, yes, I did paint everything 0 with the neck being 1. So that's good too, it's seeing it. And lastly, I can select V-skin and I can say, oh yeah, okay, everything is what I wanted it to be. Perfect. If it wasn't working right, then what you might see is instead of numbers, you just see nothing. You come in here, and when you toggle something, you see how these little white dots are popping up. Those are the verts. Those are the verts that make up this model, but there's no numbers popping up with it because there's no actual V-skin. That's because this model in particular is a drop model. It's not rigged. It doesn't need to move, so you don't have the V-skin layer on it. But if you were doing your model and you messed up, and for whatever reason the system doesn't see the V-skin layer and it's not reading it properly, or the T-skin layer or whatever, when you toggle these, that's what it's going to look like. Nothing's going to pop up. So that's how you can double check your models. And that's how you can also double check that you're rigging right. And that also brings me into just making the inventory models. The drop model and the inventory model are the same thing. So all you need to do in Metasequia is quite literally not make a V-skin or a T-skin layer. You can make a priority layer, and you should put the priority as 0 because it's going to be on the ground and players could be walking on top of it. But then all you do is you just move the armor down to the ground like that, like it would be visible. And then from above, this is what the inventory sees. So that's all you have to do to change it. And then there are some inventory editors out there that you can use to fix even further from there. So that's basically everything that I had to talk about in the process of how it goes through. I'm just going to talk about a few issues that I've seen real quick and how to spot them in game. And then other than that, I'm done. And again, later I might actually put out a tutorial where I'm modeling and doing the whole process of rigging everything, but I walked you through rigging. And then along with this, I'm going to be putting out an updated chart based off Ziva's. Credits to him for the original. an updated rigging chart that shows you the full priority T-skin and V-skin layers for the male and female model, so that you can follow it as a guide. Because like I said, once you understand what I'm talking about with the colors and everything like that, you could literally just have the chart up next to you. You don't need my tutorial or anything. You could just have the chart up next to you. You could make any model you want and just reference that for all of your rigging purposes. And then in the same, if you're trying to make something new and you want to rig it to something in RuneScape's cache, you need to copy the animations. So you can take an existing model that you want to copy and you can export it through here, and you can see the different layers and everything and see how it moves, and you can make a model that replicates those movements and then rig it and copy the rigging, and then it'll copy the animations. So real quick, this is a priority issue. This is what I talked about with the rendering levels and how the system knows what to render on top of what. So normally a chest has a higher priority than legs. Right here, I made a skirt, and the skirt happens to actually go up above the chest plate. And because I didn't bother to make the priority right here higher than 4, it was all just 1, the chest plate renders on top of it and cuts it off. So you're seeing the chest plate above that. Quite an easy fix. And then same thing, when it was moving around, the arms were rendering a little bit under here. So that's what a priority issue would look like in game, how you can spot it, and then you would just go back in the priority layer in Metasequia and you could fix it. Second thing is misaligned models. So like I talked about in Metasequia earlier, getting the verts to line up with models and where they're supposed to go and stuff is how you keep models from not being lined up like this. When you don't check and make sure that it lines up with the character model, the original character model from RuneScape, you might get some models that get off-placed like that, and it just looks janky. You see it when you get gaps in between the neck and the head. You'll get gaps in between the torso and the plate down here. You'll get gaps in between the boots and the legs. Here's an example of a model not rigged. When it's not rigged, it can't perform the animation right. So when somebody moves, the model doesn't. It just literally stays in place. And you see that because he's literally just gliding. There's no movement to be performed. So if you import a model and it's just not moving like that, you did something wrong with the T-skin and the V-skin. You can also see there's a priority issue because his chest is rendering through the wings. And that's because the wings are not a high enough priority layer. So the modeler needs to go back and fix that. And then lastly, I just want to talk about rendering real quick. These systems are not made to render a whole bunch of high definition models. It was made back in the day. So I just want to give an example. Here is a pretty generic coin that I made for a server one day. Not that in depth of a model, but still a little bit more intricate than like, OSRS would be making. This G in particular took up a lot more verts than it actually looks like. So when it renders in game, you can see here, it doesn't do a great job of actually articulating those forms. The game will try to optimize performance. It'll try to slowly collapse your model down to be viewed better and better as it gets smaller and smaller and more detailed. So just keeping that in mind as you're making your models will vastly improve what you make. I really hope this tutorial helped you guys. It was a little bit longer, and I know it's just kind of me yapping, but it's a lot of great information, and I hope you got something out of it. If you have more questions, feel free to DM me. Have a great day.